You ever look at a plant, maybe in your garden or a huge field, and see its leaves turning yellow? You know it's getting watered, the soil is supposedly rich in nutrients, but it still looks sick? Well, today, we're going to solve that exact mystery. It's a fascinating chemical puzzle that affects growers everywhere, and the solution is something called chelated iron.
So here's the big paradox that kicks this all off. You can have soil that is jam-packed with iron, a nutrient that plants absolutely need to survive, and yet the plants are showing all the classic signs of iron deficiency. They are literally starving in the middle of a feast. So how is that even possible? It all comes down to some tricky chemistry happening right under our feet.
All right, to really get to the bottom of this, we first have to understand the evidence. The crime scene, those yellow leaves. This isn't just a cosmetic problem. Not at all. It's a huge red flag for a much deeper issue that can seriously slash the yields for really valuable crops.
Now, the technical term for this is iron chlorosis, and that name tells you everything. See, chlorosis comes from chlorophyll. That's the green pigment that lets plants do their photosynthesis thing, create energy from sunlight. And iron? It's a critical building block for making chlorophyll. So you can see where this is going. No available iron means no chlorophyll, which means no green color, and you're left with a very sick and very unproductive plant. Okay, so if the iron is physically in the soil, what's stopping the plant from actually using it? Well, the answer is a kind of chemical trap. The real culprit here isn't a lack of nutrients, but the way those nutrients get locked away. Right, so here's the crucial point. Iron in the soil can get chemically locked up. Depending on the soil's pH and what other elements are hanging around, the iron ions bind with other molecules and basically become insoluble. The plant's roots just can't absorb this locked up iron, no matter how much of it is there. It's kind of like putting a giant padlock on the refrigerator. All the food is in there, but nobody can get to it.
But what if you could somehow protect that iron from the padlock? What if you could give it a key, or better yet, a bodyguard? Well, this is where the hero of our story comes in, a really clever chemical solution called chelation. It's an incredibly elegant answer to a super frustrating problem.
Think of a chelate, that's the chemical doing the work here. Think of it as a personal bodyguard for the iron nutrient. Its whole job is to find the iron, wrap its arms around it, and then safely escort it through the chaotic, chemical battlefield of the soil all the way to the plant's roots where it's desperately needed. It literally shields the iron from getting tied up and locked away.
Now, the science behind how this bodyguard works is really cool. The chelate forms this super stable protective ring structure all the way around the iron ion. This chemical hug is strong enough to shield the iron from all those other molecules in the soil that want to lock it up. But, and this is key, it's also designed so the plant can easily break it down right at the root, releasing the iron exactly where it needs to go. It's just brilliant.
So this isn't just some cool lab theory, it's a technology that has some seriously powerful real-world applications. So let's take a look at a specific formula that puts this elegant chemistry to work in a very, very practical way.
What you're looking at here is a fine brown powder called EDTA-FeK. This is a specific type of chelated iron, and it's also combined with potassium. It's engineered to dissolve almost instantly in water, which is absolutely critical for modern farming that relies on things like drip irrigation. And this table just lays it all out, plain and simple. Look at the difference. Standard iron salts, they get locked up easily, so their bioavailability is low. But the chelated form, maximum bioavailability. It's highly absorbable. And it's not just a single nutrient, it's a dual-action formula. Then you look at purity and stability. It's ultra-pure and it works across a whole range of soil pH levels, not just acidic ones. This means less waste, better results, and a much wider application. It's a total game changer.
So let's break down that formula a bit. First up, you get a high iron content, 12.4%. This high concentration means you're going to see a really rapid reversal of those yellow leaves we talked about. It's a fast, effective shot of the exact nutrient the plant is starving for.
But it gets better. This formula also delivers 10.2% potassium. And why does that matter? Well, potassium is a powerhouse nutrient. It improves the overall quality of the plant. We're talking bigger fruit, better taste, and making the plant tougher and more resistant to stress. So you're not just greening the leaves, you're actually boosting the quality of the final harvest. Now, for any large-scale farm or growing operation, purity is everything. And check out this quote from an engineer. The industry standard for insoluble stuff, gunk, sediment, is 0.1%. This particular product, it tested at just 0.01%. That is a full 10 times purer than the standard even requires. It's pretty incredible.
And that 0.01% number, it's a huge deal. Why? Because in modern agriculture, fertilizers are often pushed through super expensive drip irrigation systems, micro sprinklers, you name it. Any sediment can clog these systems, causing tens of thousands of dollars in damage and downtime. This level of ultra-purity is basically a zero-clog guarantee that protects the grower's incredibly expensive equipment.
So as you can see, the story of chelated iron is about so much more than just turning yellow leaves green again. The impact of this kind of precision technology ripples across the entire growing operation, from plant health to the bottom line.
So, let's just wrap it all up. With this one solution, you solve iron chlorosis for rapid greening. You deliver essential potassium for a higher quality crop. Its incredible purity protects critical, expensive equipment. You reduce fertilizer waste because the nutrients actually get used. And it works almost anywhere because it's stable across a wide range of soil conditions. It really is a complete precision nutrition solution.
And that leaves us with a pretty cool thought to chew on. We've gone from just dumping fertilizer on a field to literally designing a nutrient's own personal bodyguard to guarantee its safe delivery. It really makes you wonder, right? If we have this level of control over a single molecule, what's the next great leap forward for precision agriculture? What other natural limits are we about to overcome with some clever chemistry?